Big Mystery in the Perseus Cluster, presented by Science at NASA. The universe is a big place, full of unknowns. Astronomers using NASA's Chandra X-ray Observatory have just discovered a new one. I couldn't believe my eyes, says Ezra Bulbul of the Harvard Center for Astrophysics. What we found at first glance could not be explained by known physics. Together with a team of more than a half-dozen colleagues, Bulbul has been using Chandra to explore the Perseus cluster, a swarm of galaxies approximately 250 million light-years from Earth. Imagine a cloud of gas in which each atom is a whole galaxy. That's a bit what the Perseus cluster is like. It is one of the most massive known objects in the universe. The cluster itself is immersed in an enormous atmosphere of superheated plasma, and it is there that the mystery resides. Bulbul explains, the cluster's atmosphere is full of ions, such as iron-25, silicon-14, and sulfur-15. Each one produces a bump or line in the X-ray spectrum, which we can map using Chandra. These spectral lines are at well-known X-ray energies. Yet in 2012, when Bulbul added together 17 days' worth of Chandra data, a new line popped up where no line should be. A line appeared at 3,560 keV, or kilo-electron volts, which does not correspond to any known atomic transition, she says. It was a great surprise. At first, Bulbul herself did not believe it. It took a long time to convince myself that this line is neither a detector artifact nor a known atomic line, she says. I have done very careful checks. I have reanalyzed the data, split the data set into different subgroups, and checked the data from 4 other detectors on board 2 different observatories. None of these efforts made the line disappear. In short, it appears to be real. The reality of the line was further confirmed when Bulbul's team found the same spectral signature in X-ray emissions from 73 other galaxy clusters. Those data were gathered by Europe's XMM-Newton, a completely independent X-ray telescope. Moreover, about a week after Bulbul's team posted their paper online, a different group led by Alexei Boyarsky of the Leiden University in the Netherlands reported evidence for the same spectral line in XMM-Newton observations of the Andromeda galaxy. They also confirmed the line in the outskirts of the Perseus cluster. The spectral line appears not to come from any known type of matter, which shifts suspicion to the unknown, dark matter. After we submitted the paper, theoreticians came up with about 60 different dark matter types which could explain this line. Some particle physicists have jokingly called this particle a bulbulon, she laughs. The menagerie of dark matter candidates that might produce this kind of line includes axions, sterile neutrinos, and moduli dark matter that may result from the curling up of extra dimensions in string theory. Solving the mystery could require a whole new observatory. In 2015, the Japanese Space Agency is planning to launch an advanced X-ray telescope called Astro-H. It has a new type of X-ray detector, developed collaboratively by NASA and University of Wisconsin scientists, which will be able to measure the mystery line with more precision than currently possible. Maybe then, says Bulbul, we'll get to the bottom of this. For updates from the Perseus cluster, stay tuned to science.nasa.gov.